Hello students, today we will study about the exercise 4.2. This is the topic of standard 10, chapter number 4, quadratic equations. So in previous class we have studied about how to solve the quadratic equations by factorization. So based on that concept, today we will study two word problems. So from the word problems, first of all we derive the quadratic equation and then solve the quadratic equation by factorization method. So now today we will study question number 5. So what is the question? Question is, the altitude of a right angle triangle is 7 cm less than its base. If the hypotenuse is 13 cm, find the other two sides. So what we have given here is, there is a right angle triangle. So let's suppose M and O is a right angle triangle. First condition we have given is that its altitude is 7 cm less than its base. So as the given triangle is a right angle triangle, this side MN will be the altitude and NO is the base. So we have to find out both this side, the base NO and the altitude MN. One of the side MO is a hypotenuse that we have given as a 13 centimeter. Okay, so let's suppose that the base is x centimeter. So here our base is NO and let's suppose it is x centimeter. Now according to the condition given in the question, the altitude is 7 centimeter less than the base. That means the base is smaller, the base is greater. So we can define altitude as x minus 7 centimeter. Whatever the base value, we have to subtract 7 from the base, and that is why we get the value of altitude. Okay, so now we have base is x centimeter, altitude is x minus 7 centimeter, and hypotenuse is 30 centimeter. So according to this, now in triangle MNO, angle N is 90 degree. So we can use the Pythagoras rule. Now we have all the three sides. Okay. So now according to the Pythagoras rule, MO, that is the hypotenuse square, is equals to MN square plus NO square. Now put down all the value of MO, MN and NO. Now MO is 13, so 13 square is equals to MN is x minus 7, x minus 1 square plus NO is x, so x square. Now 13 square is 169. Expand this according to the identity, we will get x square minus 14x plus 14, 9. And this is x square as it is. Now this x square and x square is 2x square. This minus 14x remains as it is. By taking this 169 to the right hand side, it will subtract from this 49 minus 169 is equals to minus 120 is equals to 0. So this is now a quadratic equation we have formed from the given situation. Now we will solve this quadratic equation by the factorization method. But to do the next process, see here, all these three terms has a 2 as a common factor. So by cancel out the 2 as a common factor, what will remain here? X square minus 7x minus 60 is equals to 0. Now it is easy to factorize this by splitting the middle term method. So we have to factorize 60 such that the subtraction of both the factors is 7. So what value we get here is 12 5 is 60. So x square minus 12x plus 5x minus 60 is equals to 0. We split the middle term, or we write down the middle term in another form as minus 12x plus 5x. So by making the pair of first and second term and third and fourth term, what we will get? By taking common, here x is a common, so x minus 12 remains in the bracket. 5 is common here, so x minus 12 remains in the bracket is equals to 0. Again x minus 12 is a common from both this term, so take it as a common. What will remain? X and plus 5 put down in the another bracket, that is equals to 0. Now we will compare one by one this bracket with the 0. What will happen? First we compare this x plus 5 is equals to 0. So the value of x here we get is minus 5. But what we have supposed x as? X we suppose as the base, and that is the length. So is the length in minus is possible? No, length is not possible in minus value. So this value of x is not possible. Now compare this x minus 12 with 0. We get x is equals to 12. So our base that we have supposed as x is equals to 12 centimeter. This MO base is 12 centimeter and our altitude is x minus 7. So instead of x, now we can put down 12. So 12 minus 7, that is equals to 5 centimeter. So our altitude MN is now 5 centimeter. So in this way we can solve this type of quadratic equations. Okay. So let us continue with the question number 6. What is the question number 6? The question is, a cottage industry produces a certain number of pottery articles in a day. It was observed that on a particular day that the cost of production of each article in rupees was 3 more than twice the number of articles produced on that day. If the cost of production on that day was rupees 90, find the number of articles produced and the cost of each articles. Here we have to find out the two things. One is the number of the articles produced and the cost of each article produced. So let's suppose that the number of articles produced is equals to x. So now one condition given in the question is that the cost of each article is equals to the twice the number of articles and 3 more. 3 more means to add 3, to which add plus 3, to which we have to add plus 3, twice the number of articles. That will gives us cost of each article. So we can define cost of each article as twice number of articles plus 3. And what is number of articles we have suppose is x. So here we will get cost of each article is equals to 2x plus 3. Now we have both the things in one variable, that is number of articles is equals to x and cost of each article is 2x plus 3. One more thing we have given in the question is that total cost of production is equals to 90 rupees. So we can define the total cost of the production as multiplication of number of articles and cost of each article. Suppose the number of article produced is 10 and cost of each article is rupees 5, then we can define this as total cost is equals to 5 into 10, that is equals to 50. So here we have number of articles is equals to x and cost of each article is 2x plus 3. So the multiplication of both will gives us the total cost of the production. So in this way we can define this thing. Now multiply this x. So we will get 2x square plus 3x. Take this 90 to the left hand side. We will get 90 is equals to 0. So here we have formed the quadratic equation with variable x. Now we will solve this quadratic equation by the factorization method. So here we have 90 and here we have 2. So 19 2s are 180. Factorize 180 such that the subtraction of 180 gives us 3. So that two factors are 15 and 12. 15 12s are 19 and 15 minus 12 is equals to 3. So we can write down this 3x in another form as plus 15 minus 12x. Okay, now there are 4 terms. Make the pair of first two term and third fourth term and take the common. From first two term we can take x as a common. So what will remain here is 2x plus 15. and from this two term 6 is common, so what will remain here is 2x plus 15. As 6 is common, here we have 2x and here only 15 is remain because 15 6 are 90. Now from both this term 2x plus 15 is a common, so what will remain? X minus 6 put in another bracket is equals to 0. Now we will compare one by one bracket with the 0. By comparing this with the 0, we will get 2x plus 15 is equals to 0. Therefore, x is equals to minus 15 upon 2. Now what the x we have suppose is number of articles produced. Is the minus 15 upon 2 is a number of any articles? No, it is not possible. So this value is not possible. Now compare the second bracket with 0. We will get x minus 6 is equals to 0 and therefore x is equals to 6. This plus value is possible, so x is the number of article produced on that particular day is the number of articles. So x we get is 6 and the cost of each article is 2x plus 3. So cost per article, that means cost of each article is equals to, put the value of x is equals to 6 here, we will get 6 to the 12 plus 3, total is equals to 15 rupees. So number of article produced on that day is 6 and cost of each article is equals to 15 rupees. Okay, so in this way we can solve the quadratic equation of the word problems and quadratic equations by making quadratic equation from the given situation and solve them by the factorization method. Okay, thank you.